Hello, everyone. I'm delighted to be here today to talk about this interesting topic of using filtration fume hoods in order to simplify the design and the management of laboratories and laboratories projects. First of all, let's talk about the building of this presentation, the organization of this presentation. So I will present to you how filtration fume hoods are a proven and efficient solution in order to combine the elements needed when building, designing, and also operating a laboratory. These elements being, first of all, users' safety, then flexibility of the equipment and flexibility of the laboratory, adaptability of the laboratory, reduction of the costs, construction and operating costs, and all of this in the respect of the environment. Before starting with these parts, I will tell you a bit about Lab company, which has been created in 1968 by the family Auville. It's still a family-owned company, and Lab has created in 1970 the first ductless fume hood or filtration fume hood. Then in 1996, it is an important date because it has been the launch of the first standard regulating ductless fume hood, which is the French standard NFX 15-11. In 2008, Lab has launched a new technology called green fume hood, an integrable technology of filtration, detection, and communication, which can be integrated in fume hoods from partners. This technology has known a new kick in 2019 with the launch of the Neutrodyne Unisorb, so the last generation of filters with large improvements on filtration versatility and filtration retention capacities. Today, our lab represents 3 production facilities, France, in the USA, and in China. We manufacture 4,000 ductless fume hoods every year in our production facilities. And what is also very important about our lab is the innovation. You see here a picture of our R&D laboratory, and you have to know that we invest about 7% of our turnover every year in R&D. Now let's start talking about our main topic, filtration fume hoods. And first of all, how filtration fume hoods are safety equipment. I will now tell you more about their working principle and guarantees for their efficiency. So how does a ductless fume hood work? Here you see a drawing representing the working principle of the fume hood. You see airflow entering by the front opening, going up and taking all pollutants with it. Then this polluted airflow goes through a filtration system that depollutes the air, and this air is being recirculated into the laboratory. This is why we also call filtration fume hood recirculating fume hood. So 2 factors are important: containment, protection of the users from the chemicals by the enclosure. This containment efficiency is guaranteed by the airflow, which is a barrier, an air barrier between users and pollutants. Then, obviously, filtration systems. This system is adapted to the chemicals that are filtered in order to remove pollutants and recirculate clean air back into the laboratory. Now I will show you in more detail the filtration systems. Here you see what we call the filtration column, which is the top of the fume hood. Imagine the enclosure below this part. We are looking at the filtration column from the side, and the airflow is going upstream through the column. So how does it how is this filtration column built? First of all, you have a base module integrating lighting of the fume hood, but also sensors, humidity, temperature sensors, and pre-filters. Then you have a first layer of a filter, what we call the primary filter, a neutral-dye unisorb filter, which is based on activated carbon. This filter aims to retain all pollutants and absorb them from the airflow. This neutral-dye unisorb filter has versatility, so it's able to filter all families of products that can be filtered with large retention capacities. The lifetime has an average of 2 years. It has a maximum lifetime of 4 years. After this primary filter, you have the ventilation and detection module. So this is the fan, but also in this part, you have a sensor or sensors, which are here to monitor constantly the air quality and give a warning if there is a breakthrough of the chemicals. So if there is a saturation of the primary filter. On the top, you have a security filter, also a neutral-dye unisorb, allowing to maintain the air quality upstream even if there is a saturation of the primary filter. The interest of this security filter is that even if this primary filter is saturated, you don't have to stop your process. You can keep doing the handlings, so it does not disturb the use of the laboratory while planning the replacement of the filters. The air quality upstream has to be always below 1% of the threshold limit value of the chemicals. So this threshold limit value or exposure limit value is the limit of concentration of chemical admitted in a room to maintain health of the users. This configuration, 2 layers of filters plus detection, is the class 1 configuration as regards to the NFX 15-11 standard. This is not the only configuration possible. It's the configuration that you find here for handling liquid chemicals. For liquid chemicals, you have to handle to use neutral-dye activated carbon filter. When there is a use of solid chemicals, it is possible to combine these filters with particulate filters. So here the configuration would be one layer of the base module, one layer of HEPA filter, particulate filter for powders, then the primary neutral-dye filter, the fan, and the safety neutral-dye filter. The last configuration available is for clean rooms. Here you have the primary neutral-dye filter, the ventilation, the safety neutral-dye filter, and a particulate filter on top of the column to protect the room against the carbon dust. These different configurations are determined before installation, but they are modular. So it means that after installation or after a certain amount of time, it is possible to completely reconfigure the fume hood and change the usage. On these 2 pictures, you see the filtration columns installed on the fume hoods. So here you see fume hoods with 3 columns. Our fume hoods can provide from 1 column up to 6 columns, depending on the dimensions. Now, about guarantees of performances. Compliance to the standards is an important point to guarantee the performances of the fume hoods. Our fume hoods are compliant with the most stringent international standards. Here I mentioned the AFNOR French standard, NFX 15211. This standard includes the Part 3 of the EN 14175 European standard regulating ducted fume hoods. You see here the ASHRAE, the American standard. There are also other standards that we comply with, so all the existing standards internationally. Compliance with the standard is not the only guarantee for protection of the users. What is very important when it comes to safety equipment is to perform a risk assessment before choosing the right safety equipment and the right configuration of the safety equipment. So we perform a risk assessment, a feasibility study, to validate the applicability of the fume hood prior to the installation. This feasibility study has a reference allowing traceability for the users and validates 4 parts. First, containment efficiency as regards to the manipulations that will be done in the fume hood. Then possibility to detect the chemicals handled. Then the compatibility of the filters, of the neutrodyne filters with these chemicals, and also satisfying lifetime for the filters. Lifetime of the filters will have an impact on the operating cost of the fume hoods. So this is why it is important to look at these parts prior to the installation to make the decision of the right safety equipment. Here you see an example of a fume hood M3, so 3 filtration column, providing 36-month lifetime for the primary filter. We then look at the different detectors that are recommended to detect filtration failure. With this risk assessment, we validate the usage framework, but then it's also important to allow real-time monitoring of the safety parameters. For that, we have multi-detection embedded in the fume hood. First of all, an anemometer, which is installed to always measure the containment efficiency. Air phase velocity must always be over 0.4 meter per second. Then filtration with different types of sensors. Temperature control to warn users if there is a detection of high temperature in the fume hood. That could mean that there is a fire starting, and that will lead to the ventilation to be stopped to avoid to feed the fire with oxygen. And last, humidity having an impact on the filter's efficiency and performances. These parameters, they are communicated to the users with visual and audible alarms, but they are also communicated to the outside of the lab through software, and they also can be communicated to the building management system and to the HVAC system. So now we have validated the efficiency of the fume hood, the filtration fume hood, being protecting the users. Now we are going to look at the design of the lab and the flexibility provided with filtration fume hood. First of all, let's have a look at this drawing, which shows the system to run a lab equipped with ducted fume hoods. You see here the ducted fume hood. The working of the fume hood is submitted to the connection of an exhaust system to remove the pollutant to the outside of the building. This exhausted air must then be compensated thanks to the ductwork, which is going to balance the air into the lab, knowing that the lab could be then in negative pressure, in positive pressure, or neutral. The supply of this fresh air requires to design, install, maintain a complex system, which has a cost and also which is complicated to design. Now, if we are looking at the same lab with ductless fume hood, filtered fume hood, you see here the fume hood is not connected anymore to the exhaust system because the fresh air is recirculated into the room. In this case, it is possible to reduce, of course, the exhaust system linked to the fume hood. Also, to reduce the ventilation infrastructure, because this infrastructure is then only required for the ventilation of the room, not for the balance linked to the fume hood. So the ventilation of the room linked to the number of people working into the lab. Ductwork can therefore be downsized, which increases lab working surface, technical space being reduced, technical space being either a room or a floor. Here it is a floor. So the more you have working surface, the more you can optimize the use of the building. And then all this increase the simultaneity ratio. You have to know that the ductless fume hood, because they are not depending on any exhaust system, all the fume hood can work at the same time. All the ductless fume hood can work at the same time. So the simultaneity ratio of a fume hood is 100%. For ducted fume hoods, it may not always be the case. If you have to add additional fume hoods, or if you have a large amount of fume hood in a laboratory, the ductwork may not be dimensioned exactly to allow to have 100% of the usage of the fume hoods. In this case, you have to define priorities and run the lab according to this simultaneity ratio. This is not the case with ductless fume hoods. To illustrate this flexibility and the simplification of laboratory design, I'll tell you now about a case study which took place at Butler University in the US. So this project took place in 2011, and it was a renovation of chemistry labs, teaching labs, with different goals: modernize these labs while improving indoor air quality. You see here images before renovation. Students were working a lot on benches with no protection in the fume hoods. Existing fume hoods were open and not optimized, not used as in the best way. Reduce operating costs as well. And all of this with a reduced planning, a reduced schedule, considering that these labs should be ready for welcoming new students after holidays. So I'm using here the drawings of the architects, drawings of the building before with 10 ducted fume hoods, and after with 26 ductless fume hoods using the green fume hood technology. Drawing of the HVAC system before. So 2 main exhausts connected to the 10 ducted fume hoods. And after, only 1 main exhaust. So this project allowed to remove completely main exhaust from the ventilation system. About the project schedule, the two solution has been compared before deciding to go for ducted or ductless system. So schedule with ducted system would require a design period of 4 months, bidding of 1 month, and then construction of 6 months. With filtration fume hoods, design of 4 months, building of 1 month, but construction only of 4 months. So 33% of time saved. When it comes to design of the project, 4 months being in the best case possible. Any modification on the design prior to construction with ducted fume hood would have an impact, obviously, on the ductwork and the HVAC system. So this could take more time and increase the time for the design. With filtration system, you modify the number of fume hood, it has no impact on the HVAC or the ductwork. Then now about flexibility. Flexibility of the equipment, flexibility of the fume hood. I already told you about the filtration technology. The Neutrodyne filter is versatile, and also the configuration of the filtration columns is able to adapt to the main laboratory applications and to evolve in time, to be adapted to changes in the usage of the fume hood. Sensors are wide spectrum sensors, so it means that you have flexibility of the equipment and adaptability in time. Flexibility is also flexibility of spaces. With filtration fume hoods, the impact on the building design is kept to a minimum. In this way, it allows large possibilities in the design of the building and also in the arrangement of interior spaces. It allows to have open spaces and to relocate easily, change the arrangement of interior spaces easily, which can be done at the moment of the project, but also after the installation of the building. To illustrate that flexibility, let me tell you about the concept that has been developed by one of our customers, L'Oréal. And this concept is the Flex Labs concept. So this is a concept of flexible and sustainable laboratories, which has been spread now, and it is the standard actually for all lab construction and renovation and in L'Oréal research centers. Different flex labs has been built in France, India, China, and Brazil. And in France, the flex labs in Cheville-la-Rue implies the usage of 8 filtration fume hoods from our lab. So the idea with this concept is to have shared spaces and flexible areas which are adjusted to projects with sustainability. What aim L'Oréal has is to adapt the layout of a laboratory to the project that is taking place at a moment in the laboratory in just one day. So it is possible to change entirely the layout of the laboratory in just one day to give the researchers the equipment they need and when they need it. This is cheap, it is flexible, and also it is sustainable. Here you have a picture of a laboratory in Brazil, which illustrates well the concept. You see that benches are placed on casters. Utilities are distributed from the ceiling into modular columns that can be moved around the laboratory. And this is a picture of one of the green fume hood that has been installed in the Flex Labs from Cheville-la-Rue. I invite you, if you are interested, to look at the many publications that are online about this sustainable lab, the L6 building from L'Oréal in Cheville-la-Rue. So what L'Oréal says about green fume hood and filtration fume hoods from our lab is that it meets completely the requirements of the Flex Labs because you don't need an exhaust for the fume hood, so fume hood can be relocated, and then fume hoods are consuming low level of energy, which matches the sustainability requirements. Now, let's move to the costs. Third part of the presentation, I will go back to the Butler University project, for which a comparison of costs has been done before the project between ducted fume hoods and ductless fume hoods. And first of all, construction costs. If you remember, this renovation project, the aim was to build to go from 10 ducted fume hoods to 26 fume hoods. So here we compare the cost of ducted fume hoods. $8,000 per ducted fume hoods multiplied by 26 units, making $208,000 for the fume hoods. Each fume hood needs a ductwork to run. So the cost of the ductwork, the add of the ductwork for each fume hood costs $5,000, which makes $130,000 for the ductwork. But then, if you remember the previous drawings, the building supply and exhaust system was dimensioned for only 10 fume hoods, so there was an upgrade needed. The cost of the upgrade is $300,000, which makes a total construction cost of $688,000 for ducted fume hoods. If we look at the filtration fume hood solution, the cost of the fume hood is $22,000 per fume hood. So much higher cost per fume hood. But then the fume hood the filtered fume hood does a need to upgrade the building supply and exhaust system. So the cost for that is zero. What was needed was to upgrade and modify the existing system to remove, for instance, one of the main fan exhaust. And this modification costed $50,000 with a total cost of $622,000 for the construction and savings of 59,000 euros. Then operating costs are also interesting. So they made a calculation based on 10 years operating of the lab. So for a ducted fume hood, each fume hood requires to exhaust to ventilate 1,264 cubic meter per hour, multiplied by 26 fume hoods. The yearly cost of the cubic meter per hour is $2.94, which makes a yearly cost of almost $97,000 for the fume hoods. You have to know that in this area, Indianapolis, the energy cost is particularly cheap. So it's also very relevant to know that. Based on 10 years, the cost of ducted fume hoods is $966,000. For filtration fume hoods, the cost of the exhaust air per fume hood is zero because no air is exhausted. However, it's important to have a ventilation in the classroom, requirement being 85 cubic meter per hour per person in the building, 104 person, making 8,800 cubic meter per hour for the ventilation. Yearly, this represents $26,000. In addition to the ventilation, you have to consider the replacement of the filters. I mentioned that before. The cost per fume hood is $3,000 in this case, depending on the type of filter, is $3,000 multiplied by 26 fume hoods. But the frequency is not every year. So the lifetime here was 4 years for the filters, which represent yearly $19,500 per fume hood. No, in total, sorry. Based on 10 years operating, this represents 4,500, 5,500,000 euros per for the filtration fume hoods. So a savings of almost €500,000. So the projects would cost with filtration less in construction, less in operating. A bit more about operating costs. Let's look at the reduction in airflow before construction, before renovation, after renovation. We reduced the supply air here, and we reduced the exhaust air. I mentioned that one of the main exhausts was completely removed from the ductwork. So the exhaust air has been reduced by 65%, the supply to compensate the air by 55%. The air balance has been made again. And in parallel, the working areas has been increased, going from 10 ducted fume hood to 26 fume hood. So the working area, the area of work in fume hood, has been increased by 70%. I'll finish this part about filtration, about costs, showing you a chart of energy consumption by lab equipment that has been published by the Center for Energy Efficient Lab last year. I think this chart is very interesting because it shows that fume hoods are by far the most energy consuming piece of equipment, far from minus 80 degrees freezers. Looking at this chart, you can imagine how important it is to reduce the impact of the energy consumption, to consider the impact in the global building. This leads me to the last point, which is sustainability. So as you have seen just in the previous chart, the choice of ductless fume hoods led to reduction of CO2 emission linked to energy consumption, because these solutions are less energy consuming. In addition to that, pollutants are not exhausted to the atmosphere with filtration fume hoods. So in this case, it is complete suppression of the pollution. Even if pollutants are diluted when exhausted with a ducted fume hood, they are still into the atmosphere. So this is important for the respect of the neighborhood, but it also allows to install a plant, install a lab in an area where emissions are forbidden. We can think of universities located in the center of cities. We can think also of laboratories installed next to schools and next to areas of people living. This also reduction, going back to the reduction of the CO2 emission, allows also to create zero net energy buildings or positive energy buildings. I will now show you some of our projects that have been done using filtration technology. First of all, let me show you some customers using filtration in different segments. You see here that in education, pharma, cosmetics, heavy chemistry, chemistry and high techs, customers can use filtration. And to be more illustrative, you can see here some projects. One project done in France. So first of all, some European projects. This project has been done in France at Tefal with the installation of 10 green fume hood by our integrator partner Birdinola. This is the Flex Labs in Chevilly-la-Rue at L'Oréal. You see here the fume hoods at the back, not connected, the benches, places on casters, and the utility columns. This project has been done at a Belgium customer, Ajinomoto, with the installation done by our partner Vinitex. You have here an example of 3 green fume hood installed by Birdinola at Lattice Scientific in the UK. Here you have a picture of the Bristol Community College, the Zero Net Energy Lab buildings that has been built at Bristol Community College. So this building is a teaching building, teaching medical, dental, chemistry, and biology. And this building has a neutral carbon footprint that has been allowed thanks to the optimization of the ventilation, reduction of the HVAC system of 80%, optimization also of the heating system with renewable energy produced on site, and all of this using also filtration fume hoods. So the filtration fume hoods here has helped to achieve the goals of neutral carbon footprint for this building. Another picture of a university in the US, 49 green fume hood installed by our integrator partner AMS, Air Master System. Here's a picture of the labs. You see transparent panels. You've noticed that in all the pictures I'm showing you, we have different design. The design of the fume hood is adapted to the design of the laboratory and the requirements of the users. Here, project done in China in Tianjin University with 43 green fume hood and also 27 halo system. Green fume hood are installed at the back, and the halo systems are installed on the ceiling. The halo systems are air purifiers, so they are supporting the action of the ventilation, purifying the ambient air, and also monitoring the air quality. Now a picture of Bridgestone Tech Center with 11 green fume hood installed by our partner ALC. Different integrators, different design.